Hello everyone. In this lecture, we will learn the concept of Avail list to better understand the different operations in linked list. Now, I have in this particular example taken a segment of the memory, and here there are some used blocks of the memory and there are some free blocks. Used blocks are represented by the pink color, and they represent that these particular memory locations are already occupied by some process, some program. And free locations are represented by green color, and they represent that they are currently free and any new process can take this space to run the program. Right now, every particular location in the memory has some address assigned to it, and this green location, this first green location in the memory, free location in the memory, is represented, is assigned this particular address, that is 1000, and this 0x represent hexadecimal, which represents the address in memory. And I have just taken some random numbers, and I have taken 1000, 2000, 3000, and 4000 because they are easy to speak and make you understand. Right now, so if I talk about this memory, here this is the first memory location which is free, then this is the next location, then this is the third location, and this is the fourth location. There are let's say there are 4 free locations in this memory, and they are free. Now here, in the case of linked list, we use the concept of dynamic memory that I have already explained to you. So whenever you have to assign some process to memory, so you will be the memory manager will find out whether there is a free location or not, and it is going to be assigned to that. And whenever you are done with the process, then the memory will be free. But in case of your array, you have to fix this size, and you have to insert the elements into that particular area only, the fixed size only. You cannot add more elements, and if you are inserting less numbers to the array, then the space can be wasted also. So here we will be using the concept of pointers, and in case of pointers, they are also variables, but they are some special kind of variables which are used to store addresses. So normal variables will store some value that can be a string value or a character value or an integer value, but in case of pointers, they are always going to store the address of, they are always going to store some address. Right now, here we are going to use the concept of Avail list. Now, what is Avail list? Avail list is list of free nodes in the memory. Now here the free nodes are 4 nodes, and these are the address assigned to it. And whenever we have to do some sort of insertion, so then we will be taking some free blocks from the memory, and we will be performing our operation. And here, in case of your linked list, the memory can be shrinked or it can be expanded, that we will understand now. Now again, I have taken the same memory block, and here let me make you understand how Avail list work. Now see, this is the first memory location in the given memory, and it is located at this particular address, 1000 address. Now here, this is your first node, and as I've told you, every node is represented by 2 parts. First is your data, and the next part contains the address of the next node. Now if you want to from this address to this address, if you want to go here, it is not possible, because if you want to store, let's say, 10 elements, and they have to be stored in some sequence, that is only possible with the help of array. But in case of dynamic memory allocation, you also have to, along with the variable, you also have to store some another portion which will be storing the address, right? So here we have 2 parts. So when you insert some element into this, let's say I have inserted a number 2. So when you want to insert the element 4 to the next location, so it has been inserted, but how will you go to this node? So here we have the second part, that is the next part, which is going to the store the address of the next node. So in this way, it is storing the address of the next node so that it can directly reach to the next address. Similarly, this node will store the address of the next free memory location, that is 3000, and here you will be putting some data. Let's say you have inserted 6, and again because there is one more free location, so this location will store the address of the next node, that is 4000, and you will put some data here. Let's say you have inserted again, let's say you have inserted 8, and because this is the last node and it is not further pointing to any other node, so you will store null here, which says that it is not storing anything. So if you look at this particular diagram, here these 4 free nodes are represented, these 4 free memory locations are represented by these 4 nodes, and every node is having some address. So the first node is having address 1000, the second node is having address 2000, right? The third node is having address 3000, and the fourth node is having address 4000, and every node has two parts. Now obviously when you have to travel from one node to the other node, so for that the first node will be the address of the first node will be stored in some pointer, and here that pointer is, we have represented that as avail. So this avail will store the address of the first node of the memory location, which is free, and then the first node will store the next part of the first node will store the address of the next node. So as I have told you, this node will store the address of the next node, that is 2000. The first node is storing the address of this node, and then this node is storing the address of the next node, that is 3000. So this node is again storing the address of 3000 that is being assigned to it, and then finally this node is storing the address of the next node, that is 4000. So this is being this node is storing the address of the next node, and in the case of last node, because it is not pointing anywhere, it is storing null, right? So this is how an avail list look like. And please understand this fact that memory is not organized this way. It is not the actual representation, but to make the user understand how we are organizing the memory, and to make it learn and understand in an easy way, we have just created this logical concept. So, and let's say now I have to, these are the 4 free locations. Now I have to insert something. So now how will we do that? Now let's understand it. So here I will take the first node from the avail list, and this is the first node. And here I have inserted some data. So initially in this avail node, avail list, all these data are empty. So this will be filled only when we are taking the nodes from the avail list. So let's say I take the first node. So this first node is being taken, and here after taking the node from the avail list, and when you are creating your own linked list, then only you are going to enter the data. So this 2, 4, 6 and 8 are not initially stored. Whenever there is a request and you need to put some data, then only you will be storing some element to it. Earlier, otherwise it was not having any elements being stored into these free locations that I have inserted 2, 4, 6 and 8. These were inserted later on when they were being borrowed from the memory. Now when I have borrowed the first node, that is being borrowed from the first from the avail list, so this will be no more available in the avail list, and it is taken by the user, and the address of this node is, as we can see, 1000. So it is also 1000, right? And in case of your linked list, there is one more pointer, that is start pointer, which will store the address of the first node. So this start is storing the address 1000. Now as this node is no more there, then this avail is going to point to the next node in the avail list, that is 2000. So earlier it was storing 1000, that is the first node of the memory, but now this node is being used by the user and it is occupied. So because avail is storing only the free location, so the next free location is 2000, and this free location is no more available. So then your avail will point to the next location. So this will be the next free location, and from there all the free locations are connected. So similarly, now let's say again I have to take one more node, and I pick this node, and I have taken this node here in my linked list for storage of some program. Then again this node is no more there in the memory. So earlier it was deleted, and now this is being deleted. Now when it is being deleted, now this avail is no more going to point to this address 2000, but it will point to the next free location, that is 3000. And this, because we have borrowed the second node, which is having what address? 2000. So this is having 2000 address. So here in avail, the address now stored is 3000, that is the third node. And all these two locations, the first location and the second location, are occupied by your programs. Now this first node is having address 1000, which is stored in the pointer start, and the next of this node will contain the address of the next node, that is 2000, right? And here we will place some data. So let's say I have inserted 2 here, as if I talk about this example, and in this case I have stored 4. So similarly, you can add more nodes and take it from here in the avail list. And let's say I have just taken 2 nodes for insertion, means you want to insert just 2 elements. In that case, this is the last node and it is going to store null. So this is how we This is how the Avail list are being explained. And this is how whenever you have to insert anything, you're going to borrow some nodes from the Avail list for storing some data. And once, let's say if this means program completes its execution, then this memory will be freed and this will be again given back to the Avail list, and then it can give some extra memory. So both the memory can be expanded or it can be shrink. So this was all about Avail list. So in the next lecture, we will be learning about the different operations which are performed on linked lists. Till then, stay tuned to my lectures. Thank you so much.